Okay, so what form is that? It's an equation. So one of the forms we know that they don't have numbers, or this is nothing official, but we're going to talk about the three forms. So the first form is the equation. That's one way we can represent a linear relation, or any relation actually, but we're mostly worried about linear relations right now. So an equation is, and we talked about this the other day, useful sometimes, maybe not useful other times. What's this one? Somebody else. It's just a table, that's right, or you call it a chart, like call it what you want. I'm not too worried about the word, but a table, okay? And sometimes a table is really, really useful. Some people love tables. Often, you'll find later on, the table is not the best way because when the numbers start to get big, it would take forever to make a table. So tables are limited in their usefulness, but some people love them and sometimes they are very good. And what's the last one? There's not actually anything here yet, but what do we call that? Somebody else? It'll be a graph once we're finished with it. Very good. And a graph, again, if the numbers get really big, sometimes a graph, oh, I forgot we're going to talk about that activity. We'll talk about that after, that we were doing yesterday. And some of you noticed when you were graphing that thing that happened in the activity yesterday, you couldn't answer the question because your graph wasn't big enough. And that happens with graphs. But graphs are very, very useful for some other things. And you'll notice that a little bit again later on in a few weeks when we explore some other things around these linear relations. So we've got three ways that we represent or we show or we can communicate linear relations. You got to know all three of them and how to go from one to the other two. So if I give you the equation, can you make the table and the graph? That's what you did in the learning goal today, so I know you can. If I give you the table, question number 2 here gives you the table, then you have to figure out what the equation is and draw the graph. And then on the back of the page, you'll notice that C, the third example, gives you a graph. This is one we haven't quite done yet, but I bet you'll be able to think it through and figure it out, but we will talk about it together when we get there. How do I turn that into a table and equation? Okay, so you can go ahead and get started on this first one. I know you know how to do this first part. You've probably already started. I'm going to try to get caught up here. Raquel, help me out here. What do I put in this row besides 0? 4. And I'm going to guess, everybody look up, that came from right there. Is that right? Is that what you did? So the thing, this is so important. Before we move on, I meant to do this. Again, pencils down, eyes up. What are the 2 most important things about a linear relation that we need to know? Was that a hand up? No? Do you know what they are? You remember either of them? Yeah, it's just the actual words. Okay, good. That's good because we're getting there. Remember I said it might take a few days, it might even take a couple weeks, but eventually everybody's got to answer this. What are the 2 important things about linear relation, about a graph or whatever it is? Whether it's an equation, a table, it's all the same. The 2 important things. Justin? Not quite. Those are 2 important things, but they're not the things that I'm talking about. They're the 2 things that are going to help us get started, at least, on almost every question that's involved in a linear relation. Brandy? One of them is the change. What's it changing by? How is it changing? Very good. Savannah, what's the other? Where does it start? Awesome. Where does it start? What's the change? Where does it start is what we just answered. It's 4. It's the thing that you just add. It's the thing that's not with the X. There's lots of different ways to think about this. But once you practice enough, you'll remember. But if you're making that mistake, that's what you need to figure out today. Like that's what you need to practice. And every time you do one of these questions, where does it start? What's the change? So where it starts goes in the 0 row. And then the change tells me what I'm adding. So 4 plus 3 is 7. plus another 3, I should have pluses in there just to show I'm going up, is 10, plus another 3 is 13, plus another 3 is 16. I almost said 17. I'm going to do that actually. I'm going to say 17. And I'm going to show you something that's going to happen. But you put 16. 16 is the right answer. How could you know? This is tricky. And this is something that might take a little bit more time. But if you were writing a test, how could you know, and you forgot, you were drawing a blank. I'm looking at this, y equals 3x plus 4. How can I remember which one is where it starts and which one is the change? Answering this question might be different for different people, but I want you to just pay attention right now. Make sure you're listening. What do you think? Yeah, if the number's by itself, that's where it starts. Because it doesn't, this is what I would think. It doesn't matter what x is. 4 is going to be 4. Right? This part is going to change depending on what x is. If x is 1, or if x is 2, or if x is 3, or if x is 4, that part's going to change. And how much is it changing by? It's changing by 3. So maybe that's a way that you can think about it. X is the thing that's changing. So the 3x is changing. 3 is telling me how much it's changing by. Okay, and I want to remind you, when you have a grid like this, you got to draw in your axes. So use a ruler and draw in your axes like that, please. Yeah, there's one right there. And then I can graph like this. I can say, where does it start? Well, I should put in my numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is x, and this is y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to keep going up 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so I start at 4 because at 0x, I'm at 4. So I go up to 4 here. Put your pencil down and just watch for a minute. We did this yesterday, but this is going to help us when we get to the third example and we have to think about a graph. The change was 3. So every time I go over 1, I go up 3. 1, 2, 3. Right? So I'm going over 1 and I'm going up 3. Over 1, up 3. From 7 up to 10, just like I did here. So I look at this, watch. When x is 2, y is 10. When x is 1, 2, y is 10. I can plot the points like that, like we did before as well. And I can think about how, if I'm given a graph, can't I look at that change between points and figure out what the change is to develop the equation? I can look at this point to see where it starts, right? Moving backwards, moving between the different ones helps me understand all the different types. Okay, so I'm going to plot a few more of these. Let's see. At 3, I'm at 13, so I'm over 3, and I'm at 11, 12, 13. And take a look at 4, I'm at 17. So at 4, 15, 16, 17. Now I'm going to draw a line. Watch me draw my line. Hey, what happened? What happened? Some people know what they're doing and everything's going well, and then all of a sudden you try to draw your line and something weird happens. It's the number that I made a mistake on. And I kind of did that on purpose, but sometimes that just happens, right? We're like you add 3 wrong in your head, or you hit the wrong button on your calculator. And this is what happens. The point's not on the line, right? Of course it's not. Because I didn't add 3, I added 4. So it changed it. So if you're ever trying to line up your points with your ruler and something's not quite right, I bet you added slightly wrong or you counted wrong when you were putting it in. And so this point should have actually been at 16, right there. I'm going to go back and fix that. 16. Okay, everybody got that one? Still not working? Any questions? All right, remember the three forms. This case, the first one we were given the equation, we had to come up with the table and the graph. Now you're given the table, you got to come up with the equation and the graph. You can do it whatever order you want. Again, go ahead and get started. All right, lots of people have noticed something interesting about this one. So maybe what you did first is you went to the table and you said, okay, I'm going to figure out what the change is. From 12 to 10 is what? Somebody help me out here. Minus 2, it's down 2, very good. And then down 2 more. And then down 2 more. 6 to 4 is down 2 more. So I notice that it's going down. These values are going down. The 2 is a negative, so that shows that it's going down. And if I'm writing my equation, Jacob, what is my equation going to be? So where it starts is 12. Jacob started with that and wrote the 12. And then notice that the change is going down, so the change has to be minus as well. Very good. Minus 2x. Folks, watch carefully. I could write it like this. Minus 2x plus 12. Some people maybe always want to write it in this order. But look where the minus sign is. It's on the 2 because that's what's going down. The 12 is positive. That's where you start. And then I go down from there. So either of these two ways is fine to write it. If I wrote it like this, 2x minus 12, that's actually not quite right. I mean, you're on the right track, but it's not quite right because that says where you started is minus 12, which is possible, but it's not really something that'll come up for us very often. Okay, very good. I'm going to get started on my graph. Yes. Yeah. We'll get to D. Well, for D, you're not supposed to really go that far ahead, everybody. But for D, you're going to end up making up your own. So make your own, but all three have to match. That's the idea. But before you do that, make sure you've done it correctly, because as I walk around, I see a lot of people have not drawn in their axes here. So make sure you've drawn those in. Don't just use the corners of the grid. You draw them in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I start at 12. And then when I go over to 1x, I'm at 10. So 1x is 10 because I've gone over and I've gone down 2. And this is, again, what I really like. Down 2 more, down 2 more, down 2 more. Because I really like how all of these graphs show that we're going down, 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 down. Make this guy blue. The line's going down. The numbers in the table are going down. The 2 is minus, so it's going down. All the things are going down. Any questions about that one? You're all gone way ahead, so I guess you don't have any questions. Okay, and this one, we have not done one where I gave you the graph and you came up with the table, but I know a lot of you have already finished it. What are you going to do to solve a question like this, just in general? What do you think? Like, where would you start? Caden, what do you think? Yeah, what do we call that? What are the 2 important things about a linear relation? The change and where it starts. Look, can't I see where it starts? Aaliyah, where does this one start? 0. I'm going to put that on my table. Awesome. When I zoom in, what's the change? I'm going to find some points on this line. You can draw them in like that or just look at them. What is it going up by? It's going up by 2s, isn't it? Can't you see that? Can't you see how this is the same as going up by 2 in the table? A graph is just a different way of listing all the points. So I start at 0. After I go over 1, I've gone up to 2. When I go over to 2, I've gone up to 4. When I go over to 3, I've gone up to 6. When I go over to 4, I'm at 8. Look, here's 4. Here's 8. So for 4, I'm at 8. And I can see the change happening here as well. Plus 2, plus 2, plus 2, plus 2. So when I go to write my equation, does anybody want to try to write this one for me? Y equals 2x. You might have said 2x plus 0, and that's fine too, but we don't even need the plus 0. And in that case, we're allowed to be lazy and you don't have to write it. But some people like to, and it might be a good idea to do that just to remind yourself, hey, don't forget where it starts. Like either way, just whatever you're comfortable with. Fantastic. I love it. Okay, so for D, you're going to make up your own. You got to make sure it fits on the graph. And make sure that your equation and your table and your graph all match each other. Don't make it too crazy or too complicated. And then I've got some practice for you to try a few more of these as well. I want some different examples of some of the equations that you came up with. So Ethan, can you give me the one that you did? 6 plus 3x. What did you come up with first? The equation or the table or the graph? The equation first. Okay, who else has one? Kaden, do you have one? What did you do? Yeah. 7 plus 7x. Nice. Noah, what'd you do? 3x just plus 0, right? 3x. Very nice. Anybody else? Who else did one? What'd you do?
I did
Minus 2x plus 18. Nice. Anybody else? Justin? 5x plus 5. Nice. Whoops, plus 5. So take a look at all these if you want to. This one starts at 6 and goes up by 3. This one starts at 7 and goes up by 7. This one starts at 0, goes up by 3. This one starts at 18, goes down 2. See how very quickly you can get a sense of each and every one of these. They all have the same things. They all start somewhere and then go up or down from there by the same amount. And I could very quickly go ahead and graph all of those. I have one more question for you. I'm just going to do this first. Could I go up by like a decimal, 0.5? What would that look like? So let's say I start at around 3 and I go up by 0.5. Yeah, I could do that. And doesn't that mean if I went over 1, I only go up a half. But if I go over another one and I go up another half, now I've gone up a whole because I've gone up 2 halves. Oh, I got that frozen, sorry. Right? So, and then I would go over 2 more and up and 2 more and up, and it would look something like that, right? And just like Jamarly said, it would kind of go through a messy point like that, but you could do it, absolutely. So we're looking at nice round whole numbers because they're friendly and easy to kind of make sense of right now, but there are other options. You could go up or down by kind of anything, right? Okay, very good.